We're going to take abstract expressions involving fractions and make them more concrete by adding context and writing real-world word problems. Our first strategy is to start with a visual representation and then create a story around that. This is taken from a 4th grade workbook, and the 4th grade students are asked to write a problem to go along with the multiplication sentence 3 times 3/10. Well, I know that I can think of my times as of, so I could think about this as 3 groups of 3/10. And I'll have to figure out 3/10 of what. That's implied in the fraction 2. We have to have some whole. So I'm going to draw 3 equal groups and label them each 3/10. This linear model makes me think of distance, so maybe the 3/10 is 3/10 of a mile, 3 groups of 3/10 of a mile. And then I can just turn that into a story. Mario walks 3/10 of a mile every day for 3 days. How many miles does he walk? We can do this for any 2 numbers and any operation. So here's another one. Well, again, I can think about this as 3/4 of, that's my times, 5/6 of some whole unit. So let's switch up our model this time. Let's draw a rectangle. That'll be my unit. And then I will take 5/6 of the unit. Let's break it into 6. And then I'm going to take 3/4 of the 5/6. So this grid kind of reminds me of what a seating chart might look like. So I'm going to make this about the students in my class. So this whole is going to be students in my class. So let's start with that. 5/6 of the students in my class, what can I say about them? Maybe 5/6 of the students in my class have siblings. Okay, now I need to say something about the 3/4 of the 5/6 of the students in my class with siblings. Maybe their siblings go to elementary school. Okay, so I have the 5/6 of the students in my class, and then 3/4 of those have a sibling in elementary school. So we have to have a question. Now, this is where people often mess up in these fraction multiplication ones. They say, well, how many students have a sibling in elementary school? Well, that doesn't quite work because I never told you how many students I have. And maybe I have a really small class of 12 students, or maybe I'm the music teacher and I have a large ensemble and I have lots of students. So I can't answer how many students. Instead, I can ask the question about what fraction of my students. 5/6 of the students in my class have siblings. 3/4 of the students with siblings have a sibling in elementary school. What fraction of the students in my class have a sibling in elementary school? So that was a fairly complicated problem, but I wanted to do it because of that question issue. Instead of asking about how many students, I'm asking about what fraction of the students in my class. Our next strategy is to start with a context and then add an annotated equation and finally write the story. So here's a 6th grade workbook where the students are asked to write a problem that can be solved by dividing 9/10 by 1/4. If I were a student looking at this workbook page, I would key in on the picture for a different problem and say, oh, I could write a measurement where I'm measuring out batches. I could write a measurement division problem. So in this case, I think, what could I measure out that's 1/4? Well, 1/4 makes me think a quarter, which makes me think of a quarter pounder. So maybe I'm making hamburgers and each hamburger is 1/4 of a pound. So here I'm going to have 1/4 of a pound per hamburger. 1/4 of a pound of what? Probably I should say 1/4 of a pound of ground beef per hamburger. So let's make that ground beef. So my 9/10 would be the amount of ground beef that I had, the pounds of ground beef. And I'm going to answer the question, how many hamburgers can I make? So here's a problem that matches that. Marco buys 9/10 a pound of ground beef. If every hamburger he makes uses 1/4 a pound of ground beef, how many hamburgers can he make? So here I thought about the context. This context, I used a measurement, or how many groups, perspective of division. And then I thought about, well, what could I measure out in batches of 1/4? 1/4 a pound, 1/4 a pound of ground beef per hamburger, and I made a story from there. Let's say I chose the other perspective of division. Let's say that I went with a partitioning, or how many units in one group. So I have 9/10 divided by 1/4, 9/10 total units, 1/4 of a group, and my question is going to be how many units in one group. Now here it can be helpful to think about rates. Units per group, right? This could be miles per hour. What other rates can I have? I could have pages per minute. I could have pounds per dollar, cups per recipe. You get the idea. So think about a rate that you can come up with, and then the first unit becomes our total, and the second unit becomes our groups, and we can just fill it in from there. So I'm going to go back to my ground beef problem, and now I'm going to think about maybe I need to store my ground beef, and if I buy 9/10 of a pound of ground beef, so I'm going to have 9/10 of a pound of ground beef. Maybe it fits in 1/4 of a storage container, so 1/4 of a Tupperware. And so the question is, how many pounds of ground beef in one Tupperware? So this was pounds per container, or pounds per Tupperware. I had my units were ground beef. There's my units are ground beef in one Tupperware per Tupperware, right? That my group became the Tupperware. So let's write that problem out as well. So we have, if 9/10 pound ground beef fills 1/4 of a Tupperware container, how many pounds of ground beef fit in one Tupperware container? It occurs to me that maybe not everyone knows what Tupperware is. I'm dating myself from the days of Tupperware parties. They're just storage containers that you can put in your refrigerator. These are just a couple of strategies, but the idea is to add real-world context to abstract problems, both as a skill for a teacher to help students put some context with their math. And then also, as you can see, students are asked to do this as well to demonstrate that they understand when they would ever use this kind of mathematics.